Welcome to our tutorial about creating relations. In this tutorial, we'll learn how to create relations between tables. The first question which might come up, what's the point of using a relational database with relating tables versus a more simple flat Excel sheet or something like this? Now, in some situations, you may not need to use a relational database. In fact, it's a really good idea to keep things as simple as possible and never to overcomplicate your design. Remember, you're the one designing the database, so do keep in mind some basic principles. Number one, the database has to be robust and it has to be convenient, and it has to provide the necessary data integrity. Another point to take into consideration is whether or not you're creating a database from scratch, or if you're expanding an existing database. You need to consider whether your database has to interact with other data that already exists in the database. You need to think about whether your database can easily be expanded later on if it needs to be. As you must understand by now, there are many considerations you have to keep in mind when designing a database. Let's go back to our example. So far, we have a single table in our database. It stores employee information. Maybe this is just fine if this is all we need. But we need to expand our database a little bit. That's because each of our employees needs some hardware and some software that runs on that hardware. Each piece of equipment and each software product they use is associated with a vendor. All of that vendor information needs to be documented as well. So far, it's still not unmanageable apart from the inconvenience of, let's say, vendors changing their phone numbers. We'd have to update that telephone number in multiple places in our employee database. If we keep expanding this database table with additional hardware and vendors, software and their vendors, the customers that employees maintain relationships with, etc., etc. Now we definitely need to split our table into at least two tables. I've got a second table here called Inventory. I've highlighted the Employee ID field in red. That's because it's going to be common to both tables. Having a common field between both tables will let us know which equipment and products belong to which employee. It'll store the same data as the first database. We can finish designing our tables at this point and leave them as they are. But what about, for example, if an employee leaves the company and his record gets removed from the employee table, but not the inventory table? In that case, we end up with what's known as an orphan record in the inventory table. An orphan record is a record that's just hanging in the air, figuratively speaking. To avoid this problem, we can create a link between the two tables. We'll be using the primary key and the foreign key to do this. We learned about both of these concepts in a previous tutorial. Next, we can split the inventory table into hardware and software tables, and then we can link both of these tables to the employee table. We could even take this one step further and split the hardware table into two separate tables, for example, for hardware and hardware vendors. After all, one single vendor can provide multiple types of hardware, desktops, laptops, printers, and so on. Okay, now let's go ahead and add a second table. Right-click, Add New Table. For the column name, we'll call it Inventory ID. Data type, integer. We'll use this column as our primary key. This means we can't allow null values here. Let's also set the identity specification. The identity increment and the identity seed are just fine. Next column, Employee ID. We'll make it of the integer data type as well. The data type we select here has to match the employee ID data type in the employees table. We can't allow null values here either. By the way, we don't have to name this column Employee ID. We can really name it whatever we want to name it. However, it's a lot less confusing to have matching names between the primary and foreign key columns across tables. Now let's add a hardware column and a hardware vendor column. A column for software, and a software vendor column. Notice that my default data type is NCAR10. Let's change the data type. We're going to change them to varchar 50. 50 characters should be enough for the most part. Okay, we will also allow null values in these columns. Now let's save our table. We're going to call it Inventory. And click OK. Now we've got two tables in our database. Next, we need to create a relationship between these two tables. Let's use a diagram. Right-click, Add New Diagram. We get a warning message. Visual Studio wants to create a database object. That's okay. We definitely need both of these tables, Add and Add Again. Now close. Here's our diagram. Click on Employee ID in the Inventory table, and let's drag it over to the primary key in the Employee table. Visual Studio automatically creates a name for this relationship. Down below, we see the correct informationship. And the primary key column from the Employees table is Employee ID. The foreign key table is Inventory, and the foreign key column is Employee ID. Let's click OK now. We'll set the foreign key constraint property to Yes. Setting this property to Yes enforces the relationship and doesn't allow us to delete records from the Employee table if we still have related records in the Inventory table. Click OK. And let's save. We'll accept the default name for this diagram, Diagram 1. Click OK. Yes, we want to save these tables to our database. Now we've got two tables, a relationship between them, and a diagram. Let's close everything and check it out to see how it works. Right-click. Here in the Employee table, we see employee IDs 1, 2, 12, and 16. Let's enter some data now in the Inventory table. Employee ID 1. We'll give him a desktop. It'll be from Dell. And let's leave the software and software vendor columns empty. Now for our next entry, let's use an employee ID 4. I happen to know this employee doesn't exist. Let's give him a laptop. Vendor is HP, tab. As you remember from our previous tutorial on creating tables, the red exclamation mark lets us know that the field has yet to be saved to the database. Now when we click Tab, we get a warning message. No row was updated. The data in row 2 was not committed to the database or saved. Visual Studio gives us an explanation as well. The insert statement conflicted with the foreign key constraint. This refers to the foreign key constraint property that we set to yes just a moment ago. Let's click OK. And let's change the employee ID to a valid ID, 12. Now we're able to save this data to the database. This concludes our tutorial about creating relationships.